Good afternoon, everybody. Welcome to the session, an insight into Destination Earth and the data lake services, the edge services. There are a couple of people in the room before we start with the presentation and the setup. It's done in two parts. We have a coffee break there in between. And before we start, there are a couple of people which were not registered and still want to participate, so it's possible. So my colleague shows here the Destination Earth core platform. So the people which have not registered for an account, if you go to platform.destiny.eu, and we just do this beforehand, before we start with the stuff, because then I can send to my colleagues your username so that you are onboarded on the edge services and can follow the rest. Then, Serena, if you scroll a bit down, there is then on the left side appearing, it's a bit hidden, there is register. Yeah, stop, Serena. It was on the left. You scrolled out of view. Yeah, there on the left. If you go platform.destiny.eu, if you click register, and then below is new user register. If you fill this out, it's only a few information needed, and then provide, you have everything, everyone has something to write and a pen, and if you did not do this, you just give me then your username that you registered, and then we actually start with the presentation and stuff, and in the background some colleagues will onboard you in the Edge service so that you have access. And we have some tutorials which require actually an upgraded access of your account. That might be not working in the short notice, but we will also have a workaround. We will put then later on a username password that you can use to access the digital twin data when we have some exercises, some sessions. So I just give you a couple of minutes. Can maybe the ones who still register raise the hand so that I can see you two? You need to also register, or you've done? The approval, okay, then it's no problem, but I guess it should work for you to access the edge services. It's just the twin data, and then if you use the username password later on, that should also work. Also for you.
Thank you.
Someone else missing a block and a pen? Everyone has it? Welcome. You're in? Good. Yes, just write me there on a piece of paper your username. Okay, just give me the paper. Okay. So no one else needed to do the registration, or someone? No? Okay, perfect. Is it me starting? Okay. So, good afternoon, everybody. So we have now two sessions in front of us, 1.5 hours each, with a coffee break of half an hour. And you will have as well some hands-on stuff to be done with Jupyter notebooks. A bit of Python knowledge is needed, but if you don't have it, you can potentially also click through and do the exercises. We will be doing this with 4 people, the training. So my colleague Serena will later on come in, and Jess. And we have another 4th colleague. He's stuck at the airport. He might join us in time. I don't know when. So starting, unlocking the power of Destination Earth, a guide to data lake services. And I tell you a little bit more about it. So we have at the beginning introduction for the people who don't know what Destination Earth is or only vaguely heard about it. And then we are drilling down into the element of the data lake itself, and that is done by EUMETSAT. And we are discovering the data portfolio, then in context of the data portfolio, harmonized data access. Then we will explore how to access digital twin outputs from destination Earth. And then we have something called isolate service. That is something particular service in the data lake that people can use for their projects. And we have also a use case presentation. So what is Destination Earth? Destination Earth is an initiative from the European Commission, and it's been executed by 3 entrusted entities which have different responsibilities. So the core service platform with which you have interacted already before the start of this session today, where you registered, this is the core platform, and this is user interfacing, and that has been done by ESA. ESA is responsible for the core platform, all the services that are exposed there, and all the information. The data lake is done by EUMETSAT, and we provide discovery data access and big data processing services for people which want to solve kind of what-if questions, where you combine observation data, in situ data, and digital twin data together. And you might want to answer what-if questions, and you can do that using programming or tools and services to combine it together. Some of those aspects you can do as well at the core service platform. They are ready-to-use services, and they're a bit more lightweight. So you go in, and then you have services for which you can do as well tailored specific stuff. I show you later as well, and you explore it a bit yourself. And then the digital twins, and the digital twin engine is done by ECMWF. And here it's been based on a physical model of the Earth. And this physical model is actually used for 2 things. It's the climate adaptation digital twin, where climate projections are done, which are going into the future, based on several scenarios. And these scenarios generate data. They go in the history. Control is about the current time, and they go into the future up to 2025. And in there you find climate parameters. And in these projections, you can use them to answer some questions. So, for example, I don't know how will my average temperature be in Letland? How it will change over time. So, what is the average? I don't know, in the future. So, kind of things like that that you could do with the climate changes, etc., based on the physical models. And then there is also a second twin, which is called the extreme digital twin. And this one has is a digital twin. It's not a forecast, but the digital twin contains parameters and weather-related data for the next 4 days. So it's run daily, and it projects then for 4 days in the future. And it's also based on a physical model. Both of them have quite high resolution, higher resolution that you find, for example, in C3S in the Climate Data Store, or C3S or CAM services, but we will explore later. This is a timeline of the project itself. It was started back in 2022, and there it was the official launch, and the agreement set what everyone is doing and what the project scope, etc. Development started in 23, and we had actually the opening of the service in 2024. So it was in June in Kajaani in Finland. There was the opening of the service, and now the service is available to users. And so we still do enhancements. And we are planning into a transition into operations by 2030. So it's operational already today, but the Earth system model will be further complemented by additional models, more parameters, and so on and so on. This is another picture, but now drilling down. So you saw the 3 entrusted entities, core service platform with off-the-shelf services, and these services that you find in the core platform are meant to be also operational services, and people or industry, if they have some ideas of implementing a service around that, they can be hosted in the core service platform, and there's a specific onboarding service to for example, propose a service, to have implemented it, and then the person who has done it has to support it. And in the data lake itself, we are working project-based, so people can request access to a project or for an undertaking You could describe, for example, what you would like to do in a projection of 6 months, and then you can do your own development and take away your own results, but you're not meant to operate that afterwards as an operational service in the core platform. So it's for yourself. You can do it for research or for institutions or things like that. And the data lake itself offers 3 main services: discovery of the data set and the data portfolio, data access to the whole Destiny data portfolio. We have about 200 data sets, and then big data processing, how you can actually combine all the data together and do as well model development, etc., AI/ML, and take then the results away. And you use all the elements together, because you saw from the registration with your user account on the core platform, you access core platform services, but you can go as well to the data lake and use services there. And you can also use services to access the digital twin data with that one account. The data lake itself is based on a distributed infrastructure. We have actually infrastructure sitting across Europe, and we have actually then infrastructure there where big data holdings, where big amount of data is lying, so that we don't need to transfer it. Because when the digital twins or when the climate projections were running, 1 year of for example, a climate projection is about 1 petabyte big. And they were initially produced in Lumi in Finland. And then you had, like for 1 day, 1 petabyte. But not all of this is then transferred into the data lake. So a tenth, like hundreds of terabytes, are transferred in the data lake. And when you access the data, you cherry pick. Yeah? So you go for a region of interest, you go for certain parameters. So you transfer gigabytes then into your algorithm or something like that. So it's reduced. And so therefore we have infrastructure at locations where big volumes of data either exist or are used for processing. So in Lumi we have the climate projections. The next set of climate projections are generated at Mare Nostrum. This is in Barcelona, HPC. And Leonardo is in Bologna, and there we are still ramping up and using it as well for projections, but it's not ready yet. And then we have a sort of central site, which is in Poland, in Warsaw, and this is from Cloudfaro. There we have as well large data holdings coming from Copernicus, etc. There's many EU data resources available there directly to be accessed. And at HumanSat we have HumanSat Data Lake. Here is one video and animation, a possible journey, but I explained before you can have many ways of using Destiny. So you could come from the core platform service, you access and discover data sets. You might use AI/ML or other things. You use hosted applications, virtual machines and clusters, access and use digital twin data in the context of workflows. And these workflows produce results which you can take away, or you have your question answered. Later on today, if we have the hands-off, then we are drilling down into this picture and into those services. And I mentioned before some of the things, that the DADLF is a self-standing component, physically, geographically distributed, and we have distributed services as well. If you focus then on the diagram on the left, and you can go from the inside to the outside. So the 3 service, discovery, data access, and big data processing, is at the heart. This has been powered by edge or near data computing. It's composed of fresh data pools and digital twin outs from the data warehouse. And all of this then interacts to the outer, to many digital twins in the future, today to some of them. And we will interact as well with upcoming data spaces, yeah, or with data space sectors. And this is all user-driven data portfolio. I forgot, here's an animation. So a colleague did this, what I just told. Okay, so now we are back. So we start with a journey from a user perspective. And I have to ask Serena, is it me doing this? Or maybe you do it and I talk through. And so I suggest you all have the computer. You go to the core platform, you try to access this URL platform, the destiny.eu. Then I suggest we log in together. You click on the sign in. So hopefully you managed to all log in. Anyone who could not log in? All okay? Fine. Then what we see is here on top, there is a menu. If you scroll down, there's a lengthy description about Destiny, the platform, some additional text. You can find some articles to more description of the digital twins, the different services. And I suggest, Serena, you click on the About button. No, on the top menu. Yeah. Yes, if we click on the About button, it's a bit hidden. And then we have actually three things. One of the things is to explore the Destiny data portfolio. If we click on there, and then you scroll a bit down, stop a bit up. Yeah, so we have more on climate digital twin and more on extreme digital twins. And for example, if you want to read up more, but I guess we have later on some more explanations about it. If you click on that one, you get some more information. And if we scroll down, there's a nice, it's a bit too fast, Serena. Okay, let's show then that. You have these different simulations. And this is what I mentioned before, that on Destination Earth, there are several climate projections available. We have future projections, which are in the dark blue. And they are from different models, physical models. We have ICON, NEMO, and FESOM. They have different resolutions. And on the right side, you can see the time period. And this can be discovered in Destination Earth. You can then use these projections. They are complete. So there is hourly data of the projections, and there are about 70 parameters, I think, in the climate projections that you can explore and use. And there are also, you're already gone. Okay, we have as well in the other blue color historical simulations. You have to scroll a bit down. Yeah. You see there are in the past for the reference, and the control simulations, they are in more recent. And there's something called as well storylines, and there are as well simulations simulating, for example, a 2-degree warming in a particular period of time. And then with these storylines, you could see how, for example, an extreme weather event, how it was perceived today, how it would have been perceived in the past, historically, how bad would have been, and how it is actually, how it would look like in the future in a projection. So with a 2-degree warming. So that is, there are storylines available.
Can we ask questions?
Yes, sure.
These simulations are generated by Destination Earth for Destination Earth, or they were already available, but you are just making them available through Destination Earth?
They were generated by Destination Earth. What you see in there, there's also something called Next Gems, and that was done in another EU-funded project, and they are also existing here. But what has been labeled as Destination Earth was purely generated there. And I showed before this timeline, and it started back in 2024. No, the project started in 2022, and by the opening in 24, the first projections were available, and we continue generating those. There are further projections planned, and I show later on a slide, and there's progress, and they are complemented by newer models, by more parameters, and by additional changes.
Are they only available through Destination Earth, or you have other
The Destination Earth scenarios are in the moment only available through Destination Earth, but you can access it via the internet. So if you have the account, if you have upgraded access, then you can access it from other projects also outside. You don't need to stay in the platform, but it depends of how much data you want to take out or want to work with. It might be advisable that you do it there, depending on the volumes. But it's possible, yeah, to do it from outside. But you need, in the moment, this upgraded access, and the Commission might change the approach at the beginning. They actually put this mechanism in. So initially, when we were started, we thought, okay, it would be open to everyone in the world, so that after registration, everyone could do. But then the Commission decided that they would like to control initially who actually can access it. And then they introduced, or asked us to introduce, this control mechanism to check who is accessing that. And they want initially to strengthen small, medium enterprises, European institutions, and they did not want that we open it up and then maybe the value has been taken out somewhere else outside the EU. So they wanted to keep that, but they are sort of gradually opening it more and more. So there are corporations, for example, we have now discussions regarding the Caribbeans to support them in certain effects, and that's happening to open it more and more. But ECM.WF is pushing strongly that we do that, but it's not completed yet, but we hope. Okay, Serena, you go back maybe to the core platform itself. So under these two tabs, you can find very detailed information about the different digital twins. So there is there's actually a fact sheet paper below the links. This is the extreme. Stop. Yeah, this fact sheet. If you open it, there's quite a nice description of what the digital twin output, what the key facts are, etc., for what it can be used, and all the kind of stuff. You can explore that a little bit. Then if we go back to the core platform, you scroll a bit up. So then we have something called services. And this is what I mentioned before. On the core platform, there are ready-to-use operational self-services. And what actually happened there, ESA is responsible for that. And they had a couple of times tender open, and then they asked industry or companies to suggest services that could be hosted in the context of Destination Earth. And then a company applied and made a proposal. We believe we could develop that and that. And they made then a sort of offer to us and ESA evaluated that and then decided to fund and host the most prospective applications. And that's why we have here a big portfolio of services which are ready to use. And there are options to discover them. There are, for example, access and exploit data services in the category, and you see it in the top. And for example, Insular Code is a Jupyter Hub directly on the core service platform. Then you have things like for data access Sesame or Eden. There are different ways with different APIs to access data. Then we have the Earth Data Hub. This one offers in a cache ready-to-use data. So what is being provided there is data in ZAR, X-array, stack conformant, and a certain subset of the climate projections is copied actually to the core platform into a sort of cache, which is ZAR managed, and you can access that via the Earth Data Hub. And some of the applications are using as well the cache for example, some of the graphics you saw on the Earth, etc., that is using as well the cache. The data lake itself, you see that now down there, and this is more the focus of the talk today. We have there hook, stack, polytop, and islet. We go into detail later, and you have some hands-on there. And then there are other services which are ramping up, and I think we are now about 50 services or so that ESA will have soon available. You can filter then on top when you press more left. Where's the magnifying glass? Yeah. And then there are various categories and tags where you can filter and explore. You see the different labels of the applications, so Earth observation, processing, and it's something you can explore then later on, or when you're back home to see the different categories. If we click on one, for example, the harmonized data access, then typically you have for each of these services a description, a title, different tags. You can go to the documentation, and when you go to the service, then the service will open and the service can be used. There's some further textual description below with links and resources. And I think I'm maybe much over time already, right?
Okay, so we can continue from here. Yeah. Okay, so we arrived here at the harmonized data access. That is one of the services offered by the destination Earth Data Lake. And from here, from the desk platform where we started the user journey, we can go to the service here. And let's come back also to the slide. So we are here. We started the journey of the user, and we discovered our service, HDA, Harmonized Data Access. And from that, we land to the Data Lake web platform. So I want to start with an exercise. So if you reach the platform, if you can go there, I want to ask you to tell me, but Michael already gave the solution, how many digital twin datasets collection are available. So we can go we can see it together because we already discovered this. So basically, from here you can go to the data portfolio part and try to find. We have here 197 datasets available. You can see also the labeling saying that which kind of dataset are currently available, because sometimes happen some, for example here, some glitch with access. So, and they are categorized here. And basically, if you search for digital twin, you should have our 2 results. This was my exercise. So, from here, or also here from the category. For sure, we have other kind of category. We have marine data, temperature, and so on. And you can filter. This is going to be updated in the next days. We will have more filters, and to make it easier, browse among these 200 and more datasets. Then from there, I would like you to find the documentation and tell me which are the data lake edge services, because we saw HDA now, that is the service that it's open to each user who has access to Destination Earth. But there are also other services, the edge services, available at the data lake infrastructure. And here, from the documentation, you should be able to find out how many services we have. I will do the exercise with you, maybe. So here we have big data processing, ILET services, and we can see our instructions and also the services, the ILET, the stack service, and the hook service. So let's explore a bit more these services. as we mentioned before, we have the data access, that is the seamless access to the destination Earth data. So we have digital twin outputs, as you saw, federated data, so we have data from other providers. We will explore this part of HDI later. Our colleague will not be with us, but we will do his part here. And then we have also the possibility to expand the data served by the harmonized data access with the user-generated data. It implements a Stack API, and we will see this in detail later. Then we have the Stack services, that is basically a software as a service suite, which enables near data processing. So Jupyter Hub is part of the ecosystem, Dask Gateway, Data Cubes. Then we have the Highlight Compute, that basically is the infrastructure as a service offered by the data lake, the Highlight Storage, S3 object storage, and the hook, that is basically our function as a service part that allows to execute predefined or on workflow, but we will have a look later. Now, you already received the instructions to access edge services. Basically, at the moment, you have been onboarded in a project that is temporary. So this will be deleted later because there is a process to access edge services. The prerequisite is to have a destination Earth account on the platform, as you see. When you have it, you can access the My Service application that you can find in the Data Lake web portal and access it with the Destination Earth account. Once I put here in red the place where you have to access, you will be asked for upgrade your account, and then you, after the confirmation email, you can access this application where you can see your user profile, your project, your services, the access to the services you requested. And you can create your own project request and request edge services during this project creation. What is the process for having this accepted? The normal one, because as we said before, let me come back here. So at the moment, this application does not allow to have multiple projects, so you need to be removed from this temporary one to submit your project. So you should start requesting the edge services from the interface we already saw. You need to provide project description, your project duration, the services you want to access, so highlight, stack, hook, the quota, because each service can be accessed with different quota, and accept for sure term and condition. There will be a kind of technical pre-check from the data lake team to see if the resources are available, this is a distributed infrastructure, so your services can stay in one edge or in another one. Then there is a part of evaluation done by UMETSAT that evaluate if the user provided enough info, and in case iterate with the user, and at the end it goes to the European Commission that will approve or decline the project for sure. The parameter evaluated are the requester profile, the project relevance, and the resources available for sure. Then I would like to do with you a practical example with the Stack service. So if you go here,
you may have to show it again, this one.
yeah, yeah. You can use the QR code to access, maybe. It's easier.
Maybe you tell us about the alternative.
The Insula, you mean?
No, data. So the web portal.
Sure.
You can show it.
If you already went to the web portal, no. Yeah, yes.
Browser, yeah.
Yes. Yes, you can go here in the services page, and you can go to Stack, and you have here the go to services.
And you leave it and we check if people can do it. I suggest we go now through and have a look if you're able to do that. So in the top of the browser, you enter data destination earth.eu, and then you click on the top right on the sign in. And I'm not sure, did anyone able to access this site and sign in? It worked? Maybe? Yeah. Okay, that's strange. You're connected to this one? Okay. Jess, maybe you have a look. Someone need help? You're on the page, you signed in, that worked?
Do we need to register again because it asked me to register again?
No. Okay. So yes, there is this upgrade account step, and it asks for the email verification so that your account gets registered in the data lake. I think I saw you doing it before. That worked for you. You get then an email. Maybe you check in the spam folder to activate the account. No. Which email? Yeah. Yeah. Okay.
Can I ask you a question?
Sure.
So the data lake is a federated data lake where we have different data sets located at different providers? Or
Well, there's a federation. The lake is geographically distributed physical infrastructure, but also in the harmonized data access, we're doing federation. So not all the data is in the data lake, but for some data, there's federation to other providers. For example, to Copernicus Data Space Ecosystem. Yes.
Copernicus is there, but actually physically it's located somewhere.
Some, yes, but some data is physically accessible because there's a cache in Poland by Cloudflare, and we have access to this one at the central side. So directly via Abstract Storage, you can access it, and the same cache is available to CDSE and also to some other initiatives, and we have access it there. But some other data is federated, for example, CAMS C3S, because it's in the services. Yes, you click Jupyter full working version. So if someone goes into the Stack service itself, you click on the top, maybe Serena, you do it. And then once it's starting up, you select the full Jupyter Hub, the very first entry. Okay, you have, yes, yeah, yes. Yeah. Because your account, your username seems not registered. Can you write it down and we check that you have access from your username? Let's take the time. Did you manage? Yeah. If you click on the authenticate button here on the top. Okay, so we need your username. If you get the 403, that means you were not onboarded. Maybe write your username as well on here, so that we sort it. You managed very good. Let us have a look. Are you good to go? Yeah, that looks good. There was a screenshot. Let me come behind to see it better. Okay, you click go to the service. Yeah, there. Yes, sign in. Okay, your username is not enabled yet. Use as well, but you gave it before. We check. Serena, there are a couple of people which have the 403. That means their account is not enabled for Stack.
Okay.
Yeah. Maybe you write again your usernames on here, because it's the 403. You're good. Very good. It's okay. Okay, super. It's loading. Looks also okay. You select the top, the full environment. Very good. You're not following. You have to buy a beer. Okay, yes, looks good. And then click here. Yes, we need also again your username. It's to be enabled. Good. Yes, you click here, authenticate the top. Okay. Which email address is it? Like, I don't know, sometimes DESP has a problem with Hotmail or University. Should normally work. Check in your spam folder. Good. Good, good. Okay, I guess yours is working. Super. And you're on the mobile phone. So, can we help you somehow?
I guess so. Didn't took my
Laptop. Okay. Good. Yes. All right. Yes, the username, please. Okie dokie. This is also 403.
Yeah, I'm not sure if we're going to have a...
We try. Just give it a couple of seconds. My colleague is passing the emails. You have something? No? You okay? The ones which have the 403, there is an alternative. You could go on the core platform until this is finished, and then you could go into Insular Code, and there's also Jupyter Notebook. That's an option. The ones which have the 403. Where are you? Okay. Your username is in one word. I don't know. Ines Mendes is one of you? No, it's not you. Okay. Okay. Be a bit patient. It should hopefully come. It's maybe the network, or maybe because everyone's starting. Your username is in one word. Ines Mendes? One word. Yes, I know. But it's, we have to help. People said so. You passed all of them? Yeah. Okay. Then what we can try is show the core platform Insula. Maybe on the screen. Okay. So in the background, the team is working for the people which have the 403 to configure you. I mean, we asked last week before, but some people came a little bit later, so hence that's taking a moment. So as an alternative, what Serena shows here on the screen, we can go to the core platform. The ones which have the 403, or for the ones which is maybe not starting up, but it should normally do, you click on services. Then you search for Insula code. You click to the right, Serena, on top there. Yeah, it's in this red. Stop this Insula code. You click there, and then you click go to the service. There's also a Jupyter Hub that should work with your registration. So the ones which had the 403, that is something we could use instead until your account is done. Okay, so spawn failed. You could try again. Click on home. I think it's, yeah, start my server. Full up. And then on the bottom.
I think they just timed out.
Yes, could be.
So does this have more servers? Looks like it.
Yes, it could be. Yeah.
Well, that looks better. That looks like it worked.
Yeah. You can leave this going and do this as an alternative.
Thanks.
So on the screen, what you see is that's in the core platform Jupyter Hub, and we have the two. So the Edge service is normally on the data lake, and it's closer to our environment, etc. But on the core platform, there's also a lake, also a Jupyter Hub, and you have here as well some examples from us which we put into that instance. You find it on the left tree. You can see it, but I think, Serena, you can explain maybe Jupyter Hub, the stack service itself. On that example, show one or the other.
Okay, so basically, I wanted to ask you to access. So this is our starting exercise, and if you can access the service you have here, you can choose which kind of environment you want to start for the stack in Data Lake Lab. I will go with the full environment. And the exercise is to find the HDA examples, because there are some preloaded folder from GitHub where you can find out examples with the Edge services. And we preloaded also in Insula, that is the Jupyter Hub in the platform that we were showing before. So here we have also a preloaded folder that is called the Data Lake Lab Insula. And the exercise was to find the examples with HDA, with the harmonized data access. So we have it here. It's divided here in Insula. It's divided for kind of data. Here we have an example with the climate data service data. with digital twins and with EUMETSAT data, and this is about the method to access data through REST API. And the same here in Stack, when it's, I started the server again, so we have to wait a bit. We can have a look here for now. So these are examples with the digital twin data, the climate, the extreme data, and some other utilities. And yeah, and then we have also some notebooks that we will have a look. We will have a look later. Let's wait for this one. Because one of the exercise was to find these examples and also to find the plugins that are installed in the Stack environment. Come back here. Try to go to the description. No, because basically the service to access data is available to everyone who has registered in the destination platform. What changes is the quota you have for that, because you have a kind of different quotas. But if you are a registered user in the destination platform, you can access data. And this is the reason why the examples are also in the platform, because from the platform you can do your work, basically. Okay, basically, once you access the Stack environment, you can see that there are several plugins available. We have the S3 bucket plugin, we have the Dask plugin, we have the Git plugin, and we have the EODAG plugin that is another nice way to access data from the data lake, from the destination Earth. Yeah, because I have more upgraded access. You have access just to one bridge, to Central for the hub, and to Leonardo Bridge. It's just for demonstration. Basically, when you request for a project, you can ask to access more than one site if you want. I have the access to all the sites of the distributed infrastructure. Okay, if everyone has accessed, okay, we can describe a bit what we...
Ask if someone still has a problem.
Someone has... No?
It's working, but it doesn't start up.
Yeah, we need to wait a bit.
I already waited and I always get the error after 300 seconds.
Really? Really? Can you...
I can access this Insular, but in the Jupiter,
Yeah,
doesn't
but
start. It's the third time I tried.
I want to take a picture of the error so I can ask for support.
What's that after 300 seconds, then it's this
Yeah, this is an issue for sure.
firewall problem from my IT side.
Yes, but it should be not an issue now because we are connected with the. Cannot take a good picture. Yes, just to have a look at the user in the meantime, and then terror. Okay. When you have terror, call me. Yeah. So you were one of these. Okay. So which kind of error do you have? Okay. For this one, we cannot do much because the team that needs to give you access wanted to work in advance. We are asking, but let's see if we can.
Request the account, but I didn't receive. I starting the register yesterday.
Yeah.
It
Try to give me your name, but it's one of these.
Yes.
Okay, I already asked if they can do something. Oh, nice. So you accessed, so it's okay.
Yeah, I was just thinking whether I should go next to a specific section.
Okay, I will explain it
Okay.
a bit. Okay. Okay, we are trying to solve the issues with the user because some users registered too late. So let's see if it's possible. Then try to continue now with the presentation. Otherwise, we cannot show. Yeah.
This lady was using Insular,
Mm-hmm.
and can we see our notebooks directly in Insular or not?
Yeah, sure. Okay, so let's have a look. Here we have Insula. As we said, we have this preloaded folder. You should see the Data Lake Lab Insula. Who of you don't see Insula? Okay. But you can access Stack? Okay, perfect. So okay. Okay, so it's okay. So basically, Let's try to do on what we have. If you can access Insula, then the examples are located in this folder, Data Lake Lab Insula. And you will find inside this folder the HDA example. If you can access Stack services, you have a similar situation here. You have a preloaded folder, Destiny Data Lake Lab, and you have here a folder for each service. And in each folder, there are examples for each services. Here we have the HDA1 that are divided per type of data source, and for kind of method to access data, because HDA implements a Stack API interface. So basically you can use the API with PyStack, with REST API, or with the ODAG, that is a client, it's another client to access seamless data. And let's try now to make some work here. And so we accessed the Jupyter Hub, that is part of the Stack offering. Stack services are ready to use multi-tenant data processing solution, and they are running on the Data Lake platform, enabling data processing services. We saw Jupyter Hub here. That is the part that we access it now. There are also Jupyter Enterprise Gateway that enables users to launch Jupyter kernels at individual data sites in the distributed infrastructure. So basically you can process your data near the data. And then we have a Dask Gateway solution that enables users to request Dask cluster on demand, again on the distributed infrastructure. So you can distribute jobs across the federation sites. We saw Jupyter Lab provides, probably most of you already know, a real-time code environment. We saw that we have several extensions inside. We have the Git extension, the S3 extension, the ODAG, the Dask dashboard, and there is a specific Python DDL kernel with some preloaded libraries useful in the context of destination Earth. This is a possible user workflow with Jupyter Hub, because user can access, as you did right now, to the central site, and from there they can launch kernels on the other sites. Same for Dask. There are here in the figure we have several patterns that user can use to access and process data. So basically a user can access directly the Dask gateway on one bridge, on Lumi Bridge, Leonardo in your case, and create Dask clusters on demand to parallel processing. Another user can access through the central site and launch clusters in Lumi, in Central, in Leonardo, and only in the other bridges. So this allows to execute tasks directly from Jupyter Lab. Okay, and there is the possibility to monitor the performances of the jobs in progress through this dashboard, task dashboard that you have on Jupyter Hub. And then there is the hook part that I will leave to my colleague Jess, who is our hookman.
Hookman, okay. Hello everybody. So my name's Jess, and I should probably go to the next slide. Or can I maybe just keep you for the moment? I think we can go here. Yeah. I just do arrows here. How do I change?
You can use
Okay. Okay, so what is the hook service? I think you've heard already. It's a sort of serverless computing type solution. So that means you don't have to set up anything yourself. You don't need your own infrastructure. So basically you just need an API and put in the right parameters and you're good to go. So it's like we said serverless computing, but function as a service is another way of saying it. And we have two different categories of hooks. So the one we see here is predefined hooks. The most useful one, well, we think in general, is the data harvest hook. So you would provide your credentials and the parameters, and then you could say, I want this given collection with this given item, so product, and download that for me into the right place. And so that would be basically downloading through our HDA component. And then you've got these other processes which are available. I must admit I can't go into detail on what they are, but they're processors that you probably know if you're in the domain for doing transformations of data. So there's just on that point, then we talk about private or temporary storage. Typically, you do some. You're asking for something, either processing, post-processing of some data, and you want to put it somewhere, and you can provide, your own bucket details, or if you don't, you get a temporary storage link. The other category of hooks is the user custom hooks, so this is quite an advanced notion. You can provide your own. It's all image-based, so sort of Docker images, which get spawned, per process. In the background, it works with Argo workflows, if you know that. And so you could provide your own hook. There's a process to do that. And if that got the okay, that could be actually integrated and available for other people. So I think I should probably stop with that because I'm talking too much about hooks. This slide is basically just a bit more detail. We start with there's a notebook example. If you go to the stack, so Jupyter notebooks, there's a hook section, and you have some examples on how to execute these. So there are a couple of notebooks. You would provide credentials. You could discover the different hooks available, and then you construct your request. You trigger the hook, and then there would be some time. You would have to poll for the completion of this. It's not like sort of very quick. It can be a couple of minutes. It can be longer, depending on the activity. You call this on-demand processing API, which does the request. You get the processing happening. That would integrate with our harmonized data access component, which would pull in the data, and then, depending on whatever hook you're trying to use, that would do the processing, or just simply put it in a bucket somewhere. And I think that's enough on the hooks. I had 2 minutes, but I think I took about 10. So. All right, that's me again. Okay. So this is our next service, a bit of a hands-on again. Again, it's an edge service, so you'll need to have the account working. So sorry if you don't have an account working. Maybe just try and follow. So maybe try to go to that first link. I'll just show you. Actually, switch we've got the link here, data destination services, and try to navigate to the islet service. So I'll maybe just switch computers briefly. So I've come back right to the beginning. So with the platform, we're going to maybe navigate to the islet service from here. So you can maybe do it this way. Let's have a look what else is available here. So we talk about islet storage. So that's buckets, object storage, and the islet service itself. So let me just click here. We can click Go to Service. So we're on this page again, which explains our services. And so really, I suppose most of you are familiar with sort of public cloud, AWS or Azure or Google cloud services. This is our own version based on OpenStack. Maybe some of you know that. And if you click on Go to Service, I think the first thing to note is we've got these 5 different data bridges. So Central, I think we said based in Poland, EUMETSAT, which is in Darmstadt, Lumi, which is Finland, Leonardo, Italy, and Mare Nostrum, Spain, Barcelona. So today, if you do have an account that's working, if you click on Leonardo, and then you should come here to like a login page, just check that it's cloud.leonardo, what is that? .data, .destination Earth EU, and then you should see a region Leonardo here. I sign in. Fingers crossed. Okay, so if you're not logged in, you would have that logging in process again. Is anybody connected here? I'll give you a few minutes. I may be the only person connected. Leonardo, yeah. Oh, and did you manage to connect to Jupyter Notebook already? Okay. Okay. Okay, sorry about that. So has anybody managed to connect? Some people? 3 people? 4? So yeah, I'm sorry about that for a lot of people then. It was the Leonardo data bridge, and is anybody should have, if you access the Jupyter Notebooks, okay, you should be able to connect to this, though it's a bit strange.
But I received this error, disable insecure debug mode, blah, blah, blah.
Oh, this is Insula then, okay.
I don't know, but the previous page was this one, so I follow all the procedure you show us.
Try, yeah.
I mean, that's the...
Yeah, Leonardo, just, that's fine, there's nothing
Local
really...
case.
Oh, no. Yeah, so don't choose the Keystone account, it's the DDL OpenID.
Okay, this was my last stop.
All right, yeah. So sign in. Okay. Wow, this is really strange. I would say, if you have a problem, maybe close your browser. Close the browser entirely, all of your tabs, and
I'll try to open a new one.
well, what I do in case of doubt, in case there's some issue with sort of cookies or whatever, I just close the browser entirely and start again. But and that might solve your problem. I don't know. Or incognito, yeah. You did manage to connect to. Okay, come back to that. So I'll maybe just continue. I'll try and fix any problems in a moment. I think that we're going to do some exercises later, or I'll walk through some exercises. I think the main thing here, when you're on a... Could I just have a show of hands, actually? Are you all familiar with cloud computing, or have you built VMs, or... Yeah, a lot of people? No? Yeah? Okay, maybe half, let's say. So with a cloud computing service like this, what you can typically, the main reason is, you need a server somewhere. So a VM, and in the exercises later, we'll be trying to create a VM, trying to configure it so we can connect to it and do some work on it. So there are, I think if you've used any of these public clouds, you create networks, you create VMs, you attach them to networks and stuff. We're not going to go very deep dive today, but I will just sort of zoom in on some of the things that we want to do. So when you do connect, you will see this overview, which gives you the number of instances. So VMs, go. Yeah. So we mentioned My Services before. So the My Services is a sort of self-service sort of organization thing around there. So when you've gone through the My Services, the process is first you say, okay, I want to access this service. It's part of the edge, so there's a process. And then you will be given some resources available globally for you. So we will say you have this quota of servers, of download speeds, etc. And then you can create, with those global resources, multiple projects like this. That's the idea. So this is a project which is using some of your assigned global resources. Most people will just have one, right? So you will say, I have, Yeah. So basically there will be, if you are probably, I don't know, you're some sort of entity or research institution, you will go through some process and say, I want to use, I need some compute sources with some colleagues. One of these colleagues will be assigned as an administrator, and then you will all have access to the same space here. So that's, first thing to understand. You will see each other's VMs. You'll be able to delete each other's VMs, so that's another thing. Yeah. And also, that's another thing that's maybe interesting to note is the notion of buckets, because here in one of the, I don't know if you have access, I'll just walk around a little in the interface. So the main place you would go to is instances here. If this will work, fingers crossed. Oh. Okay, so instances is the place where you create VMs, right? So you can see I have like 3 servers running already. One is linked to an exercise we'll do this afternoon, probably, well, later on. And basically here you would click launch an instance, and then you've got this workflow. You would give it a name, etc., and we'll look at that later. And you would choose the sort of type of server you want as well, so the image, etc. So that's really the main place. People want images, they want servers, and they want to connect to servers. Just at a high level as well, there is this API access, which is maybe just interesting to note. This is a place where you can see it's a bit hidden, but you can see your credentials here, user credential details, got a username, user ID, project ID, etc. Just in case you need it at some point, sort of a technical thing. And I think one of the, I was going to ask one of the questions, but if there's so few of you connected, one of the places interesting to look here is this object store here. So you need this URL actually when you're manipulating sort of big files, you want to push it somewhere, you would need this information. What else do we have here? I'll just look at the main things, right? Container infra, clusters. So this is actually a really great part of the solution, is that we allow you to create your own Kubernetes clusters. So it's not always you can do that yourself. If you know Kubernetes, you want to sort of run images, that's a great way of doing it. You can create them, create cluster, and it's the same deal, right? You give the details. There's a process. There's a bit of an advanced feature, but we won't go into that today. But really, you can create your cluster. You can click here and get the configuration to connect to it. So it's for another day, maybe. Then there's network here, quite a nice thing on network topology. Again, sort of an advanced feature, but you would be able to have different networks inside your project, and maybe group certain types of servers together. In our situation, we're just going to have a link to the external network. Then we'll have this UMETSAT network here, which is orange, and then we'll just be creating a VM here and attaching it to this network, very, very simply. What else do we see? I won't go into everything else, but there is the notion of floating IP. So floating IP is basically a public IP address which you could attach to your VM, and then you would be able to connect to it from your PC with SSH or whatever. Orchestration, that's really sort of create sort of a process for building an ensemble of different services. So you could have multiple VMs, and it's quite an advanced subject. But for example, the Kubernetes clusters are based on that. So there's like a blueprint, if you like, for putting in place a Kubernetes cluster. DNS, just again, also if you have access to this service, you would have the ability to have your own subdomain. So you could expose your VMs through a subdomain. Again, it's not so difficult, but you need to know. And then today we'll have an exercise later on. Strangely, buckets are called containers here. And so here, to create a bucket, very simply, you would click plus container. You would give it a name, so Toto is always a good name. And then you can say, is it a public bucket available freely on the internet, or is it private, where you would need to provide credentials? So we'll actually look at that later. We can see that I've got one bucket already, which is a public bucket. You can see public access, and there's a link here. If you open that, you can see, you can access the resources. And so actually the exercise resources, we could actually go through there. I think that's probably, not sure how we are for time. Probably no time at all. In like, yeah. Yeah. So I don't know if anybody managed to connect to that. Yeah. If you think you should have access, or if you manage to access Jupyter notebooks, you should be able to access this. If you're having issues, just pull one of us over.
Okay, I spoke to our support, and for some users, they could not manage to solve the 403 problem yet, because they needed some information, which is the UUID from your accounts. And what I did is I programmed something, so when you enter the username password, then I get from the token the UUID. I can send then this UUID to our support to onboard you. So if we have the break, I could do this for some of you, yeah? So we can give that a try. I don't know if they can manage then in that quick time to do it, but it's worth a trial. The other option is I check with Serena if we can use some other username password that works, that we can share it in common, that you use one of ours from our team and we write it here and then you use that instead, because it's a bit silly that we are facing here these problems. But it's because the support team wanted from everyone all the information last week, and now they say, we don't have it, and this kind of thing. But it's a bit organizational, but we need to be as well sort of agile.
You will keep the project until the end of the conference, or how long?
Yes, I have to check with Serena, maybe a week or two or something like that. How long do we keep the project for people to access? What was agreed with Anna? Until 10th of October. Yeah. So we can try to get the UUIDs. Otherwise, I sort out a username password. We will write it here, and then you use that one. Okay. I think we do now a break, Jess. Yeah, so it's half an hour. I'm really sorry for the trouble you had, with the starting up. They also did the scaling. So for the Jupyter notebooks, we told them that we have 50 people there, extended the service so that really it should normally work for 150 users. But I saw as well on Insula that they run out of resources. So we saw here and there some messages like it was 108 instances in parallel running. So it seemed to be that they also have not catered for so much increase, because typically, I don't know, there are like 70 users in parallel, and then suddenly we have a big boost, and everyone is surprised here. Okay, then thank you, and I hope that second half will get a bit better.
No, that's fine. It's not for everybody. We're having some account issues, so.
No, but it's also, I know that sometimes people perform so many things ongoing, and even if you were registered before, it could have been overlooked. show also there. There are no use cases. Go to documentation. It's not the latest. No, it's not the latest. Go to the community website. No, right? This one. Hello. Welcome back. So I'm glad that you returned to us and not you stayed away. We lost some people because of the difficulties. I hope second part is getting a bit better and you keep a bit motivated. We had some interesting discussion over the break with one or two people. What I want to show to you, maybe not for everyone, is the hands-on interesting or so. There was a general discussion as well of how Destiny or the whole thing, like the data, can be used. And Serena, can you navigate to the Destiny community webpage, or is it that? Yes. So it's, you see, it's a slightly different with the URL. It's destination-earth.eu. And if you go to this website, and there's a lot of material from the community that you can find to browse through. If you click, for example, on the use cases, and there you can see what, for example, there were certain use cases procured by the 3 entities or by the commission or by people. And you can filter there by organization, ECMWF, UMITSAT or ESA. And then you can see various use cases which were done in the context of either using the climate adaptation digital twin or the extreme weather and geohazard. And so, for example, if we slowly scroll through, so for example, no, if we go a bit up, okay, we had, for example, here, this is one agriculture use case. So it was about, for example, crops, and you can read up there how this was used, and it was used with the climate digital twin, for example. And you can find some kind of description of what was done, how existing data was combined, for example, with the climate projections output, and what was studied and what was the result there, and how it was implemented then in the Destiny ecosystem. If we go maybe through some other examples. If you go back to the full list outside, Serena. No, these use cases were done in the context of Destination Earth. They were funded by the Commission or by the 3Es with the money provided by the Commission. So there were the countries allowed to participate which are part of the Destination Earth program and the associated countries. But the outputs and the results shall be available to anyone to look through. So there should be no limitation. Some of the stuff produced data as output, some others have actually services running, maybe ending up in the core platform, and some others have as well code available or other shareable results. You have to have a look on a case-by-case basis what the outputs or the deliverables were. If you scroll a bit down, so for example, here this one interesting, the urban heat. This I explained to something, and this is, for example, this was on a study of, for example, heat develops, for example, in cities, etc., and what it means in the future for citizens as well, hospitalization and all kind of stuff. So that is, for example, very easy to understand, and how actually this was done, all this modeling, and what are the conclusions. Then we have stuff, if you go out again, Serena. Scroll a bit down. The algae storms, air quality, changes of water cycle we have in there. Scroll a bit down. The Nube Delta, we will show later on example at the end. Something about renewable energy. Then we had, for example, dust or energy in Catalonia. This was done on the data lake. University was doing some developments there in combining the data together. And here you see the kind of what-if questions that you could ask, and that is maybe realized then. with the available data of the digital twin outputs. Because maybe you ask the question, yeah, why can I do it not on other platforms? So the big difference of Destination Earth is that we have these climate projections at hand and explorable, and the geohazard and the digital twin, which is run on demand. And then, for example, if you have somewhere a crisis or a flooding or a severe weather event, then on demand you could scale into the particular region and take out these values. And here, this is the particular element where Destiny stands out. Yeah. So with these digital twins, which are available to you, and they can be combined with other Earth observation data or data from other data spaces, and that helps you then to raise these what-if questions and solve it on the platform. So that is the ultimate goal. But yeah.
Can they run these services on the platform as a free, or they have to pay for these services that you are running on the platform?
Okay. On the platform, all the services in the moment are for free, so there are no commercial or services for which you have to pay. The services that are hosted on the core platform, they are sponsored, so ESA is part of their engagement. They sponsor the services, they ITT, they select it, and they host them. They host them for a limited period of time, and then they re-evaluate and assess. You find on the core platform as well some statistics of how much a service is used, how many users are using a particular service per month, and they watch that throughout the list. And if a service, for example, is not appealing or not interesting, they would consider moving it out and maybe bringing some others in. In the future, it could be that you have paying service or commercial services, but the Commission has not decided yet to go that way. Okay. So I think we go back to the normal track, unless you have some questions to what I just mentioned. Okay, we go back to our tutorial.
Okay, it's the HDA part. You want to do the part from Oban? As you prefer. Yeah.
Okay, I start, and then the hands-on is done by Serena. So in this chapter, we want to look at this harmonized data access. And we have coding examples in this URL in GitHub. What is in GitHub is replicated into the Jupyter notebooks in the folder. When you click on HDA in Insula or on the Stack service, you find many coding examples to access various kind of data. So the climate data, Era 5 data, satellite data, and the digital twin data. The harmonized data access here, the idea is to sort of have one API to access all kind of data, or find, search, and access all kind of data with the same API, because we have many services around Europe and in different platforms, and they have slightly different APIs. And here with the harmonized data API, the idea was to have one API with which you can access all of the data. 200 collections are in there. You can use the one credentials that you have created on the core platform. Various data providers are integrated. I listed some of them. It's stack-based. We have the digital twin collections in there. And we can go next slide. This is an example of how the Stack API is being listed. So my colleague is stuck at the airport, so he wanted to do actually the presentation because they implemented that one. It's Stack, the interface. It's version 1.0.0. You can discover the data sets, free text search. You can specify a temporal extent and the area of interest, and then you find the data sets matching these different criteria. There's a notion that what we call collections is a high-level description of a data set. So for example, I don't know, let's say Sentinel Olchi instrument, that all the data from that one can be called as one collection, and then in the collection you have individual items to access or assets. You can then, on the next level down, filter as well then on the different items that you have, and here you can specify again temporal area of interest and specific properties that a data set supports. You can go to the next slide.
I like the fact that we have also data sets with Just trying to substitute our colleague. So you put here the custom properties. So we have several federated data providers, and each provider can have its own filters. So not just a temporal extension or area of interest, but also specific filtering for that kind of data set that are covered by this interface, because there is an endpoint where you can ask which kind of parameter you can use to filter the data you are requesting.
Okay, next slide, please. This is an example of the different data providers that are integrated in the harmonized data access. I think one of you asked me earlier before is whether we have all the data in the data lake or whether we also dynamically access external data sets. And we do this as well, and this is called federation. And that's more on demand. So for example, we don't have in the data lake, we don't copy all the data in. So we have certain data in the lake available, like the digital twin outputs. Some Earth observation data is cached, like Copernicus, etc., is available on the central side. But we also have access or seamless access to other federated sites, which are searched. And then when you found the data is accessed from there. And so in the harmonized data access, you can, all of those that are listed there, we access these other sites for finding and accessing data. Here's an example of how the authentication works in the notebooks. So we had a lot of trouble in the first session. So I mean, the desk credentials is with what you had registered in the core platform, your username and password. This is the desk credentials. And then in the notebooks, they are used to actually obtain a token on the core platform, and the token is then exchanged on the data lake itself into a DDL token. And that's why before the people were asking for this UUID in order to work out what your username is. But it's all done in a package automatically in the notebooks. And the only thing you have to do is you have to pass username, password. But in the next release, we are providing as well API keys. So you can request then on the Edge service an API key, and then you can configure that one and use it instead of username, password, and they are longer living and a bit easier to manage. The next slide. Now I'm going to practical exercises, and I hand over to Serena.
Okay, so for, I don't know how many of you accessed Jupyter Hub. Basically, we need to go there and look for for this tutorial that is in the REST folder. Let's go there. No. Okay, so basically you should be here. You should see this Destiny Data Lake Lab. If, which one of you can do this? We have it divided per services. Let's go to the HDA part and to the REST folder. That is one. Okay, so here, we can choose this quick start example to have a practical view on how this works, basically. Let me... So, what we do in this example, we will discover some data sets, we will authenticate using your desk credential, and we will search for data and download some data from using HDA API. So basically we install some modules, define some constants that are basically the endpoint of the service and the collection that we want to access. Then we can use the API. We are still not authenticated because we can discover a dataset without authentication. So basically, we have here an open search where you can put your keywords, your what you want to search. In this case, I put something about chlorophyll. And we found that we have 27 collections with this kind of description, with kind of words in the description or in the title. And we choose one of these. And now we want to search data, so we need authentication. We need to authenticate with our credential. I don't know if someone is doing this right now, or are you okay? Are you okay? So I will put here my credential, my desk credential, so you should have the same. Basically, just who can access Insula and Stack has already an account as yours. So it's not needed if you do not have the upgraded access. Yeah, for the islet it's useful, but now if they can access here, they can use their own. Okay. So we authenticated, then we search our collection. We put here some parameters that are the default Stack ones. So the time and the area, we put a bitbox, and let's search for data. We have our results here. Then we decide to download the first item. And that's all. This is how you can access data with HDA. And this is only for downloading data. I don't know if you were able to have your data. Let me know. Okay. We can have a look at an example when after accessing we can also visualize some data. So we have here this one. No, this one. You can do the same exercise on Insula, because the notebooks that we are showing are also in Insula. Maybe I can do the same there. Here.
just want to ask a question. The question was, is there a sort of limit for the data access and the quotas? And it's linked to your account. So there are settings as well which enable you how many requests you can do per minute, per hour, per day, and also the volume. It's resource based, and that can also be upgraded if it's not enough. And it's going all the way through on the edge services for the harmonized data access, and for the digital twin access also on Insula. So it's regulated. But typically what you have per default should be enough unless you download, I don't know, years of data. Well, with CDSE, for example, we are linked, Destination Earth links to the other organizations, and we're using a system account, and we arrange quotas. So, for example, we talk then to CDSE and say, okay, for Destination Earth, how much can we have, how many parallel requests, how much volume, and that's then for the whole Destiny, for the data lake, then limited. But we have higher volumes than a standard user. Yeah. But I don't know, if we would have 1,000 users in parallel going to CDSE, then it would not be enough. So they typically size it for a certain amount.
I'm showing here that you have the same example in Insula. So if you can access only Insula, you can go here on the Data Lake Lab Insula. Then in REST, you will find the example that we just ran. And we are now going in this folder, data, and running this notebook that will access to the MSG data. Again, we will show how to authenticate, search, download, and access data. So basically, these are the same steps we already did. So I just put my credentials. And then we define the endpoints and search for data. Again, we will download the first of the list because in the search you have more results, for sure. And let's download it. We have to wait the end of the downloading, waiting for this round to be empty. Okay, we downloaded the data and we also unzipped because it was in a zip file. Now we are going to use the SatPy package that is a package that supports reading this kind of data. It's not in the library already installed, so let's install the package. I don't restart the kernel because I already have it. And this will allow us to read and load data. We have here all the data sets provided inside this kind of data. And we can inspect one band, for example, here. We can see this is loaded in an X array. We can see the properties and also inspect some metadata and visualize data. The simple bands are also already prepared combined bands here. So we can choose among one of these already provided by the package, and we decided for the natural color. So we can crop for an area, as we did here. and look only for I choose Italy. And we also can decide for another combination of bands that will enhance other features. Like here we can see infrared, cloud infrared. And that's, this is the hands-on on HDA for this part that are not related to the digital twin. Then we have later a part with the digital twin for which you require this upgraded access. And now I want to ask Jess to talk about the data portfolio. Yeah.
So this is a slide we just missed before. I'm not sure if we can see very well, and I think Michael's already said, you know, the different sources of data we have. On this poster we can see it's really categorized into three areas, and one we haven't talked about yet. So digital twins, it's the main collections for what we're doing, the most interesting and high resolution, etc., like Michael said. Federated data sets, Michael also mentioned. We've got about 200 collections. We call those collections in the stack language, and that's maybe a thing just to note. We use a protocol called stack, and at a high level, we have a collection, and so that describes, it's like a, really just what is the collection, temporal extent, etc. And associated with that, we've got items. So, you know, it's quite a technical thing, but that's how we integrate all of the data into HDA. One thing we didn't talk about here was user-generated data. We had one person just before asking what that was. So we're hoping, and we have at the moment sort of people like you doing your own interesting work, maybe a derivative of, you know, some of these collections already, and you might say, well, look, this is good work. I want to try and, you know, can I make that accessible through our system as well? So there is a process. You can't just click a button and it goes in. So you would have to say, look, I have some useful data. I think it's useful for the community. And then we would give you you know, there would be a process on how to do that. Basically, that's, you know, you would have your data. We would give you a structure of how to do that, and then it would generate some metadata. And, you know, that would be resulting in a collection metadata and items metadata. I don't know if you can click on the data portfolio link just there. Go to the data portfolio link and choose, you know, the first collection. Zoom. So we've got a collection here. If we click Learn More, click go into it, zoom into it. So here, when we click Learn More, we're actually seeing the collection data. So there's a description. You can see there's a temporal extent, etc. Gives the map. The description can be quite large. In this case, it is. If you go down a little. And well, actually, this is an unusual one because it's the climate data, so there's a lot of parameters associated with it. At the end of all these collections, we go right to the bottom, Serena. You see some links here. So click the third link, this one. All right, whoa, and then Pretty Print. So this is actually a stack collection, and if it's, you know, it's quite big. But basically, if you want to propose data to be integrated, you would provide a file like this. We will give you some guidelines, and if you just quickly go down, Serena, just look at the kind of information. You know, there's a thumbnail, there's parameters, there's DOI kind of information, and we would help you generate the metadata and package it. So there is a process, like I say. It would have to be validated, but it is possible. So I think that's.
What's the difference between the user-generated data that you might present versus adding another federated source?
Well, federated, sort of federated sources are sort of official sort of EUMETSAT data or Copernicus or whatever. If you go back to the poster.
So it's just about the level?
Yeah, it's official. So federated data would be, you know, there would be APIs in the background and all of that. The user-generated data would typically be packaged in a sort of, it would be exposed through object storage. So it would not be, there wouldn't be an API behind it. It would just be put in there. And we've actually got a...
Sorry, I only wanted to add the user-generated data is for projects, for example, which are onboarded in the data lake. And you, for example, do your what-if question, and then you have output or results, and you want to share the results with others. So you did it on the platform, or maybe some other people did it somewhere in Destiny, and they want to share their results with others, and then this is what we call the user-generated data. And the federated data is from outside, from another data provider, have the access via APIs.
And maybe just very quickly, I don't know if you can go to GitHub or GitHub page, Serena. So this is our main sort of GitHub examples, and you can see there's a folder here, user generated, and it's also in our read the docs documentation, which we maybe haven't looked at so much, but in that project in GitHub, that will show you, you know, what to do. I think that's enough.
Okay, now we have the, we missed one part on the, we have the ILET services in practice. I cannot find it. So you want to put your laptop just? Yeah.
Okay, so I'll try and do this relatively quickly. I'm not sure how good we are for time. We're maybe about 25 minutes or so. We're going to have a look at the cloud platform again and try and do some. So up until now, in terms of code, we've been looking at notebooks, with Python, executing Python inside them. I've taken one of those notebooks, extracted the Python code just as an example, and we'll now execute it on a virtual machine. So just to say, you don't have to execute code just on notebooks. For those that didn't have an account today, try to connect with this account. You should have access to everything except the upgraded digital twin code. So I think the first thing, let's just walk through that and get a hands up if people can all connect. So we can start, I think, where can we start? Yeah, so if you didn't have an account, just go to platform.destiny.eu, and you should all see that. If you have an account that works, use that account. If you don't have an account at all, use this. So this is all in lowercase, Jess_Burford, BURFORD _ It's not because I think I'm a star or anything, it's my company. It's a bit embarrassing seeing your user and password. So, so this is my password, D uppercase, ESP, that's a dash, Jess-star-1234 plus. Just tell me, everybody, if you can log in with that. And then we'll get on. So I will actually try and log in myself. This will be embarrassing if it doesn't log in. All right, so Jess Burford Star here. Sign in. Apparently I'm signed in. Good. Okay, so anybody trying? We just go? If you can't log in? Okay, let's just go. Right, so services. Let's navigate to the islet service. Let's go to the service. And let's click again on Leonardo. So this is where we're going to be creating our VM in Italy. Let's click on that. Everybody here, then we sign in. Okay, so strangely, or maybe not strangely. So here is a bit confusing in a way. In the documentation, it shows you anyway. You click on, make sure desktop open ID is selected, authenticate. So that should go through automatically because I was already connected. We'll get redirected here. Everybody here. Okay. So what we're going to do is look at, I've prepared some exercises on GitHub. So I don't know if that's big enough. I've got the URL here as well. So the exercises are actually here, GitHub, so Jess with a capital J, BUR, capital B, EUM, /BiDS'25. Hopefully that should go to the same place. Okay, let me try and find that. So we have here some islet exercises. All right, so I think it's quite ambitious to have 6 exercises, but some of them some of them are simple, right? So Serena is telling me I talk too much, so I will. It's a common problem with me, so I'll we'll only do a few of these anyway. All right, so we've done. I'll just give you an overview of what we're going to do. So I don't know if this is too small. All right. So typical cloud stuff. You don't have to be a developer or anything. Somebody has to tell you once, you know. So I'm going to tell you once if you don't know. So we're going to, the big blue box up there is Leonardo, our cloud space in Italy. We are going to create a VM on the left. Maybe I'll use the mouse and not my hand. So we're going to create a, can we see? We're going to create a VM. You're going to create your own VM with its own little name. So I would say Leonardo dash, then your name with maybe initial dash VM1, whatever. We're going to be choosing a type of image, so a type of distribution. So this will be Ubuntu. Maybe you've heard of that, most of you. We're going to be selecting a flavor of computing. So basically this means how many CPU or RAM, disk, etc. you got. We're going to be attaching, so this is the ambitious part, we're going to be attaching a public key and have a private key locally. This will allow us to SSH into the image, so we can get in there, but I think we'll leave that part out. I think already if we could just use the interface to create these things, that would be enough. And then the idea of the exercises is we do something and then we push something to a bucket. This could take a long time, but I will just go through it briefly then. So if you're all in here, the first exercise is called key pair. If I can find it. Oh. And there is a README and sort of some instructions. So I will show you how to do this, and then you can maybe try and do this. It's very, very simple. Actually, no, I have to click in the right place. So there is actually a menu here on the left, key pair. You can see I already have a key pair here. Let's go ahead. Create key pair. Give it a name, like Leonardo whatever, your name and VM1. And then choose SSH key. And then just create the key pair. So I will call that actually 2. Create key pair. And that's done. So if you don't know, that would allow you to get into a server. All right, so that's actually exercise 1 done, right? You clicked 3 times. So tell me if you're following or not. And let's go. So the next step, where are we? And I think we won't go through all of this, but I'll try and I'll show you the rest myself. So, sorry? Yeah. So you would typically just create 1 key pair for a tenant, and then you would attach that key pair to every VM that you create, and that would allow you to get into it securely, instead of a user password. All right, so let's go. Exercise 1 is done. If you followed that, let's look at exercise 2. VM creation. So we're right there now. We can do all of this. The instructions are there if you want to follow them, but we can maybe just follow this as I do it. So let's go. Instance. Launch instance. Give it a name. So something like this, Leonardo, your name, VM1. Leave everything else, then next. So here, there are questions on volume or the disk, just leave it default, basically we leave everything default, but we do have to choose something here, and this is actually something we didn't talk about. We've made different distributions available for different reasons. So if you type DDL, you can see that we have these pre-prepared distributions which will help you work. They've got all kinds of tools inside of them. We've got some Ubuntu, we've got some Alma, Debian, OpenSUSE, so 4 different distributions. You can see that we have some desktop distributions, so we won't go into that today. It's a bit more complicated, but it's not so complicated really. Today I just want to choose a simple server, which will be command line. It's this one here. So choose DDL Ubuntu 22 LTS, and you click on the little arrow here. And then you should see it's selected here. Anyone can do this. You don't need to know IT. So next, now we choose a flavor. So this is basically how powerful is your VM, right? So I just put here dot X. Oh no, wait a second. X large, if I do that. Oh, I've got my keyboard is broken. Okay. I'll just choose it here then. What you're looking for is, well, my keyboard is switched over between English and French as usual. So we want to choose this one. So EO2A extra large. It's got 4 vCPUs. It's got enough resources to run the distribution we want. So you click here, and that's it. We now got a VM almost set up. Next, here we choose a network. So again, typically you just create one network and attach to that. So we've called this UMIDSAT1. And then next, this one we skip. And this one, security groups. So we have to choose something here. It's called allow ping SSH. Basically, you can't connect to your VM unless you open ports and stuff and protocols. So this one was going to allow SSH, which is on port 22. If you don't know about that, doesn't matter. Just select. Next. So the key thing, normally, if you've created a key, you should be able to select it here. So you would select just whatever your key name was. So I'm going to collect this one. And then next. And then you're finished. Really? Easy, right? Let's see if it works. Demo effect. So normally at the end, you just click Launch Instance. And hopefully you will see an instance appear. You have just created your first or one of many VMs you created in your life. All right, so that's the hard work done, right? You've got a VM. Now you just need to connect to it. So tell me if anybody's trying and not managing. Yeah? Source? I can't remember that. What is it? Source. Oh yeah. So the DEDS type DDL. DE. Okay. DEDL. Go down a little to the bottom. This one. Yeah. Okay, so, yeah.
On the last step, when you say select the key pair that we have already created.
Yeah. Okay, so it's good. If you've got one key pair, it's automatically selected. So you're good to go. Yeah. I had 2, so I had to choose. Yeah. So I don't know if anybody had the same problem as I maybe went a little quickly. I'll just go through that very quickly because it takes a couple of seconds. Give it a name. You go click. The one to choose, you need to filter, just put DEDL. It's called DEDL Ubuntu, this one, the bottom here. There's one thing to note as well, we didn't talk about that, but we do have some GPU resources, so that's all also on demand. So you can need that for different reasons. And we've got a dedicated image which would help you use GPU as well, just here, just as interest. So you would select this, go next, EO2A extra large, next, humidset, next. This one we leave out. This one, allow ping SSH. Next, and then you select your key. If you've got multiple, it should be automatically selected, and then it's finished. And then launch instance, and then hopefully at the end of that, you should see your VM. Anybody created a VM already? Is it just me? Marvelous. Okay, we have a few people. All right, so I will maybe take like 5 minutes just to, how much time? 5 minutes? Yeah. Let's do what we can in 5 minutes to go a bit further. We've created a VM. Now your VM is actually just private, right? We can't connect to it. It's not exposed on the internet, so we need to give it a public IP. You can see this little number here, 10, it means it's internal. So we're going to attach, and so this is a nice thing that comes with the service as well. It all comes sort of ready for you to use. You click here at the end on your VM, and you should see this this option, associate floating IP. So a floating IP means, you know, it's in a pool of IPs, it's IPv4. It is possible to use IPv6 as well, if you know what that is, but we're going to do it the simple way. So I associate floating IP. So here I'm just looking in the pool of IPs. What have we got? It's only this first thing we want to look at. So I can see there's one IP available. I'm not going to select it. Maybe one of you can select that one. To get a new IP, you just click on the plus here. And then you say allocate IP. So this should actually pull a new IP through for me. I've got a new IP here, 191. Now we've got 2 available, and we say associate. So we've just pulled in a public IP, which is accessible by everybody. And then we should, oh, wow, look, what's going on here? I've refreshed. Marvelous, look, you're all working. Okay, all right. It's just me. Okay, no, all right. I've lost mine now. Where's mine? Okay. Yeah, this is my one here, down here. So you can see what I've associated a floating IP, and I've got this number now, 217, etc. Exercise finished. You've actually done most of it. I'll just take maybe the last couple of minutes to finish. Go, yeah. It's okay? Good student. Everything's working. All right, so the next thing is how to connect. So there are easy ways which are not so useful. One is you can actually click on... oh, it's funny, I've called them exactly the same. Oh, maybe that was me. Okay, oh no, I called it the same name. All right, so you can click on your VM here, you see the details. You can click on a tab here, console. And I would say don't use this right now, but this would give you sort of a simple way to get into your VM without SSH or anything. So there is actually a problem with keyboards. You know, if you've got a keyboard which is not QWERTY, you would have issue with characters here. But I just show you that as the simple way, as like a workaround. You can. There is a user called EO console that's in the, and that would allow you to get into it. I'm going to try and use our key pair. Yeah.
You say the console is not QWERTY.
I have a French keyboard for my sins.
Because the default is a QWERTY console, a QWERTY keyboard.
Yeah, so it should be okay. It should be okay if it's QWERTY, yeah. If you follow the exercise, it would show you that you can initialize a password here, and you could actually get into the VM just by using the console. It's not ideal because you're quite limited. For the rest, I will maybe just show you what you could do. maybe in your own time. So actually, let me just, there are different options, right? So, and I probably won't do this, but we've got through to exercise 4 now, which is connecting to your VM. So I will not actually do this because it will take some time, but maybe if you want to later. There are different ways of doing this. One is with VS Code, which is a free, really good development environment. Maybe some of you know that already. There is a procedure on how to connect that. You need to set up your private key to do that. You can also do that from the command line. Basically, when you created a private key and a public key, the private key was downloaded on your PC. You would need to put that in somewhere, and then you would execute this command, SSH-I, then the name of your private key, which you've just downloaded. The user on all of our images is EO user, which you need to know, and then you would put the floating IP that you've just associated. You launch this command. It's probably the simplest one if you haven't got VS Code installed. You launch that command, and you should actually be connected to your VM. Other tools are PuTTY, which maybe you know, but there's a bit of a thing to do with that. Me personally, you know, I just use VS Code to connect to that. And I've done that previously. And actually what you can do, if you know Git at all, when you're in your VM, you can just clone this, what we're looking at here, you clone that into your VM. So you do git clone and then this. That would pull in those examples into your VM, and you could actually execute them in part. I think that's for another day, right? So, but the exercises are there if you want to go further. They're quite simple, but it would take some time, I think. I think the main one, really, which is interesting, is when you're maybe connected with VS Code. I've taken exercise 5 here, and there is a bit of a script which installs Python. Well, it does everything basically. It installs Python, and that it executes the PyStack example, which is from a notebook. So at the end of this, actually, I'll just try and run that. Fingers crossed. If you do follow, oh, right. Oh, okay, wait a second. Invalid. All right, so there's a problem with username, password. That's another part of the exercise, just to show you. To do exercise 5, you would actually need to modify this file here with your username and your password. And then that should actually work. That would use the Destiny Lab library, and that would just launch the same code that we see in the notebooks. But I'll leave you to do that another day. We'll maybe stop here. So actually, we've done quite a lot there. Basically, that's the main part. Create a VM. You do something on your VM. You push it to a bucket, and then you're ready to do something else. Thank you.
Thank you, Jess. I think you have access till 10th of October to that. And in case you want to dive in a bit more depth, what Jess just highlighted, it's very short to give this. And then you can explore that until the 10th of October. And in principle, with the virtual machine, you have a remote computer available where you can deploy software and can do development of code, etc., these kind of things. Harmonized data access we showed before. Now we focus a little bit on the digital twin outputs and show you various ways. There's more to that, what we already talked. At the beginning, we showed the portal, the core platform, and when you went into the data of the digital twins, you could follow some pages where there was a fact sheet. But here on that slide is the same information is from the fact sheet, the climate change adaptation digital twin. On the graph in the bottom, you see that we have 90-year plus simulated years. Resolution is from 5 to 10 kilometer. Then the climate simulations, they are available historical and projections in 3 different models, NEMO, FESOM, ICON. These are different models, and the storylines on the bottom, some sort of things. With the QR code, you come directly to the fact sheet. Go to the next slide. And here's the same as the fact sheet for the weather-induced and the extreme digital twin. There's also the fact sheet, and I think if you click, okay, I thought there was as well a graph with the resolution, etc. No, there's not. Then that we saw before. On the platform, you have many different services. Maybe after the session today, you are inspired and you want to look and play with some of the services in the core platform. You could have a look. There are some interesting ones with which as well visualize plot data where you can do various things, look at various parameters. And I want to give as well another round trip. We have many ways how you can access data and work with data, and the harmonized data access in the data lake is not the only one. And here you can see the different services through which you can access federated data, digital twin data. There are many ways of doing that. So I think we have that on a later slide. We go next. The registration we had here, this, yeah, you go back to the slide. One back, yeah. And for the different ways, what you can see is on the right side, climate adaptation digital twin. These projections are available in the HEALPIX projection, and the extreme digital T lat long projection is available. That data is generated on the HPCs. It's put into a hypercube. The hypercube has a service in front of it. It's called Polytop. That's a service from ECM-WMF. So it's a bit a level down than what we do in HDA. Here you have the full extent of spectra that you can use on parameters and all the capabilities. And you can as well access the Polytop directly from the core platform, from the lake. You can use the HDA. You have to go back again. No, back. One back. To the overview diagram. You can access via HDA, Polytop, to get to the data. And then Eden Sesame, for example, is using the HDA embedded and expose another API. And then the cache management takes data from the Polytop, and then certain services use it. So it's a complex ecosystem. You have a big choice depending on which APIs you like. So there's a variety. So you have to see what is for you the most useful. I would say if you combine, access multiple data sets, then HDA could be your choice, or Eden or Sesame, or the cache. If you only work with climate DT data or extreme DT, you could also go straight away to Polytop. It's both possible. We go to the next slide. These are the highlights or the key facts about Polytop. This is sort of directly accessing on the hypercube from the outputs. You were too fast. Yeah. So here it states that it's the original unaltered representation server-side on the fly, direct access to the freshly computed data, but that's also available through HDA. In the cache copy on the core platform, there is a small difference. The ZAR format that is cached on the core platform has, for example, no longer the HEALPIX projection for the climate. It's projected to lat long in a lower resolution. So therefore, it was meant to serve really big masses. So if you don't need the absolutely best resolution, then you can work directly on the cache. You can go to the next slide. I think here we list about EarthKit. You saw it in some of the notebooks. This tool is from ECM-WMF. It's quite useful because it allows to handle many different type of data and sources. You asked me before about the zip file after the download, and when you access the data directly, EarthKit can actually then visualize and plot it, and you can tailor it, as Irina showed the examples, to focus in a certain region of interest or on a country, and yeah, with very few commands you can change it. Here you see an example, a plot. And it works quite nicely with all the data. So the climate DT, extreme DT, but all the other data sets that we have, they are mostly integrated with EarthKit. You can plot. Go to the next slide. This we had already. We go further. This we had also before. Next. We talked about it, so we have many examples that you can find in GitLab about the different data sets. We can go to the next slide. Insular code, we learned today already about it. It's another way. So all the examples you find as well in Insular. And then here is again another practical example. And I think it's useful we go for this one because it's quite nicely. It shows you how you can exploit, for example, a climate projection. And with this notebook, you can navigate your way through and you can easily dynamically pick out something for a particular projection and year and time. Yeah, Serena is loading it. We actually prepared also an exercise for you to do, but we will not have the time. I assume Serena prepared something where you could
So again, if you didn't manage to connect to Jupyter Earth because you had account problems, you can use this account again, but you won't have access to digital twin data. But you should have access to everything.
I assume as well that after we collected the user IDs, etc., with which you had problems, and I think the team will fix it. So from tomorrow, I assume it to work. Let's load the climate ET plotter. So you find this notebook. It's called Climate ET Parameter Plotter, and Serena steps through. You have the different kernel, yeah. No, it's okay. Okay, so at the beginning, I'll give it to you to explain.
Okay. So as for now, we did the same steps basically that we did for the previous notebook. So set up some packages and set up some endpoints. Now we are choosing the climate digital twin collection. And as Michael explained before, we have several kind of scenario where you can ask your data, and here is the kind of list of the possible scenarios. So you have the future projections, the historical simulation, and also the time extent here, the model used, and other information. And there are data both in Lumi and in Mare Nostrum. We have a note here because Mare Nostrum data are currently not accessible via HTA, but they will be very soon. So you can choose here your preferred scenario among the one listed before. So you can have a look at the table, choose which one you prefer, and each one has a kind of extension. So basically, if you are out of your extension, you will not have this available. Let's go here and so you selected one of the scenario available for the climate digital twin. And now you have several parameters available for one scenario. And you can see all of them here. You can choose one of the parameters. We like a lot the temperature, so we will go for the temperature. And here you can see the payload that you can pass to the directly to the Polytop API to request the data that you are selecting. You selected one scenario, you selected one variable. You can also ask for more variables in only one request. So temperature, precipitation, what you need. In this example, you will ask just for one. And this is the payload, the text that you need to pass to Polytop to request this kind of data. So this notebook is a kind of helper to construct your request because it's quite complex to have all the idea of all the parameters at the beginning. So this will help to dive a bit here. And for the temperature, that is a surface parameter, you can select 1 hour. You want to have it. We selected the data. We can select the hour. If it's applied, we can select the level. But in the case of the temperature, we have only these values as at the surface level. And then we can, again, authenticate to download the data. Okay, I have my password stored in my PC, so try again with 2 hands. Better. Okay, as you already saw, most of you, to have access to digital twin, you need to have an upgraded access, and I think that none of you received it, but this will help you to check if you are granted. And then again, endpoints, and now we saw the request that we can use for Polytop. Now we have the same request translated in HTA format, that it is one. And just to see some metadata here. And now let's go to order data. And to pull the API to see if data is ready, and download. Okay. After that, we can plot our data, our temperature data, and we can use these ArtKit packages to do it. We selected the Europe domain, and that's all for the access of the digital twin. Let's wait for the image. Here it is. Okay. I think we can go with the final part. Just can you help me to come back to the presentation?
So you've seen the example from the climate DT plotter. You can as well up to the 10th of October or longer, because the accounts will still exist. You can play a bit around, select various parameters, and explore a bit what is available from the climate projections, if it's to any use of you, or if you find the parameters that you expected to see. There are quite a lot, and there are a lot of things that you can study in these climate projections, but also extreme DT. These slides that just show we did it before, so I think we can skip. We actually had prepared, but due to the lack of time, I would not show Serena the use case. So we had prepared. Yes, how long is it? Because I don't want to hold the people too long. We can play, it's 2 minutes. Okay. Is the sound working?
This makes more than 150 data collections available, federating more than 10 data providers across Europe. Integrating with the European Weather Cloud, using Opera data and using the cloud services for local processing. Danube River Basin Hydrological Information System provides live data through the harmonized data access. Digital twin is Destination Earth Data Lake is a geographically distributed system. The use case aims at studying lakes' evolution in the Danube Delta, leveraging the Destination Earth Data Lake services. The Harmonized Data Access Service makes more than 150 data collections available, federating more than 10 data providers across Europe. Integrating with the European Weather Cloud, using Opera data and using the cloud services for local processing. Danube River Basin Hydrological Information System provides live data through the harmonized data access. Digital twin is accessed through the harmonized data access and processed using Stack Dask service on the Lumi bridge. The output is sent to the central site Islet storage service. Merit and Peckle are stored in the data lake fresh data pool and available with harmonized data access. Surfwater from Canes and CS estimates lake surfaces. Processing are executed with Islet compute service. Outputs are provided to decision makers through a dashboard. The Danube Delta use case demonstrates the services available on the data lake, showing how to leverage the harmonized data access, the processing and storage capabilities. Services from the data lake, harmonized data access, processing services from the data lake with Islet compute, hook and stack services allow to focus on added value analysis and algorithms. Destination Earth Data Lake is funded by the European Commission, implemented by EUMETSAT, and supported by Cloudflare, CS and EODC.
Hello.
What's your name?
I name it Laura.
Do you mean my name is Laura?
Yes.
This is not
Where
part
are
of
you
it.
from?
I'm from Spain.
Do you mean I am from Spain?
Yes, sorry.
Okay. So at least you're awake now. Was quite funny. So this was a use case example, which was actually procured and realized on the data lake itself and made up of all the things that we saw today. So all of the components were used, but on the core platform, or there are many other use cases available which use a different mix. You could go to the community portal and you could look for the different use cases. They usually describe how they were implemented, how it was done. Maybe we go back. I think we are about to wrap up. So on a different screen, the presentation, trying to pull it across. Yeah, now it's there. If you go into presentation mode. Okay, just to sum up what we learned today. So we learned about Destiny, so what the initiative is with the 3 different entities, what you can find on each of the site, who is responsible for the different things. We drilled down on the data lake itself. You learned how to register. Some of you have the upgraded account, not yet. We struggled with the access rights a bit. Then we learned how to navigate on the core platform, but also the data portfolio itself. If you go 1 slide back, 2 back, 1 more back. Yeah. And then we focused on the edge services. So Jess has shown how to create virtual machines, the computing resources, etc. Further for you to explain. We looked at harmonized data access, how to access diverse data sets using one API. There was a short presentation about Hook, about the workflows, how to harvest data. And we had a couple of hands-on, more or less successful. So I hope you can take some things away for you from what you learned today, and maybe spend some time to research until the 10th of October. And or you come back with some ideas and maybe request a project or use the resources. We can go to the next slide. Here again, there are resources where you can look up things in terms of documentation, where you can still work further with. And you can contact us on key questions. And then this is the very last slide from us. We would hope if you could spend maybe 5 minutes to click on this link and give us feedback, how bad we were or how we managed to survive with you today. So I think we really want to improve. It was a bit awkward with the security, with the access, but otherwise we could have maybe achieved to do more hands-on, but tell us what we should do better. Yeah. Thank you.
Marvelous.
The best thing is because I can't see until when the machine is available.
This, I think, because it's, did you use my account or your account? I'm not sure. It will be maybe a week or 2, but I need to check.
But in the next future, I can include the other machine with my account, or
I think
it will be expired.
I think the problem is that this is like there's a process to access the services, and you would have to be accepted into that.
You locked it out, no?
But
Actually, I cannot use this, for example, those players from training
yeah.
My personal network.
Yeah. No, I think that the resources are like, we get Mikko maybe to say, they are...
Just the code is gone, so I don't know if people, can you have a look that you just move it
excuse me.
to the screen? It goes down, otherwise, yes, put in presentation mode. Because otherwise people will fill it in if it's gone. Yeah, leave it on.
Mikhail, just a question on how long these resources are available, because this is just like a test account.